So this video we're going to further talk about the enthalpy change cycle, and we're going to do 5 examples here. So if you find that it's too easy, I recommend you to finish it on your own and then you just check the answers. But you have difficulties, you just encouraged to follow the videos one by one. So the first questions, are we're going to determine the enthalpy change or formation of carbon monoxide, by applying Hess law. If you know that carbon monoxide, actually the formation would combine the carbon with the oxygen to give carbon monoxide, but most likely it will have some side effect like giving CO2. So it is difficult to know this one. By using Hess law, we can easily by calculation to find out the formation of this. So normally the questions, they will have one equation with an unknown value, while other equations, they will give you some data. By combining these 3 equations together, forming enthalpy change cycle, then you can using Hess law to find out HF. Let's have a look how we're going to do it. So for my practice, normally this unknown equation I will put it at the top, a horizontal one, put it like that way. So remember, every time do include the states with it, because that one is very important. So we'll have O2 gas, and then they give out CO. So this one is an unknown. I don't know what is that. I put a question mark for that. So this equation I've used once. Remember, each equation used once only. So after that, I put a tick behind it, so that I'm not going to consider this one for the next step. And also I will follow the arrows. Remember, it's pointing towards CO, so I'm pointing towards CO. And I try to put down the value, but I don't know, so I put question mark here. So I follow step 1 and 3 already. So next, just random pick one. One of the equations. Say for example, I want to do question number 2, maybe question number 2. So this one, CO plus half O2 becomes CO2. So which one we have CO? We have CO here. But the equation, it required half O2. So what I need to do, I have to add a half O2 here. So I will add half O2, which is gas. But remember, after you add 1, you add all, because you add 1, you add 1 here, you add all. You add O2, half O2 here, you immediately making this equation unbalanced. So therefore, this half O2, I have to add half O2 right here as well. So you have to add half O2 here. So you add 1 on the right, you add all. Previous equation that you have balanced. So now we can apply the second equation. The second equation with CO plus half O2 becomes CO2. So this one, I will continue writing CO plus half O2. So this one I will have CO2, and in the process I run it once, so therefore it will be negative 283. And then afterwards, I will have C plus, so this one complete already, I put it tick. So last equation, will be C plus O2 to be CO2. So now you see that at the beginning, I just have 1 carbon plus half O2. It is not enough to perform this equation. But after you adding this half O2, so these will combine to be 1 O2. So the whole things will align with the reactant side for equation 1. So they point towards CO2, so I will point towards CO2. And then this one will be negative 393.5 kilojoule per mole. So write down the unit as well. So by doing this, now, I've completed the enthalpy. Enthalpy change cycle. Normally, you have 3 equations, you will form a triangle. If you have 4 equations, maybe a triangle, maybe like a square. Later on, I will show you how to do that, So now you can see that, we will have a starting point. Just like having a race, Starting point is the point that every people run out from that point, And then destination is the point that every people, after they run out, from the starting point, they will just gather, at that destination. So you can see right here, this is the point. Let me use a highlighter. So this is the point that, all the equation going out. Is that right? So this will be the start point. Where will be the end point? You'll find that the end point will be here, because all the arrow coming back here. So if this one is the start point, this one is the end point. So root A, will be coming from here. Root B will be there. Okay, so this is how we consider the root A and root B. I will find the start point first, and then we'll find the end point. So from start point, okay, we'll do like this way, then that will be root A, while the other side will be root B. Or you can consider as like clockwise reactions and also the anti-clockwise one. So this arrow is pointing clockwise, so I'll add this one together with this one, and then this one will be the anti-clockwise one, so that will be equals to this. So basically, okay, if this one is the delta HF, so delta HF, this is delta HF, is that right? So I'm going to add negative 83 equals to negative 393.5. So you just simply put this one on the right hand side, then you can find delta HF. Okay, in this situation, you have a sign, okay, at the top. Okay, so this is how we do. Have a look of the answers here. Okay, so you'll find that this one is a delta HF. They draw the same way, but you can see that sometimes, okay, they put the plus half oxygen not behind these chemicals. I prefer to put it behind here. Okay, that would be better, because after you put here, then you have to balance, and then you can see the things that, okay, they will align with the equation given, okay, in questions easier. Okay, if not, okay, every time you have to add half like this. Okay, it is not easy to do this way, so I prefer you put the extra reactant that you need, okay, behind the things. Okay, that will be the same. So the green one is a clockwise route, or the red one is anti-clockwise route. Okay, so you put the data together, okay, and then we rearrange the equation. You put delta H2 on the other side, okay, then you can do the math. Okay, remember just one thing very important. Okay, at the end, okay, you'll find out that delta HF will be negative 110.5 kilojoule per mole. Do remember, okay, the sign is very important, okay, in enthalpy change calculations, okay, because that represent exothermic or endothermic. So at the end, okay, remember, include all the sign for it. Okay, even it is a positive one, okay, even it is a positive one, you still have to write positive, otherwise mark must be deducted. Okay, so that will be the first question. Second one, okay, this one, okay, again, we're going to find formation of nitrogen monoxide. So we have a question one, okay, I'll put it here. So this one is also a very important exercise we have to do. So this one, okay, we have delta HF, okay, and now I try to apply either one of the equation, maybe 1 or 2, okay. Say for example, I use the first one first, okay, and then you see that I need an O2, but I just have only half of it. So what I'm going to do, I add half O2 here. Remember, after you add 1, you add all, okay, and then now you have, in total, you have 1 O2. So 1 O2 plus half N2, then you become NO2. So this one you have to become NO2 here, and that will be plus 34. Okay, so the next part, okay, it will be more tricky. Okay, I would use this equation, but this equation you'll find that you have 2 NO and then 1 O2, but we just have like 1 NO and half O2. If you take a closer look, actually this one, okay, just run this equation by half. So we can simply, okay, follow this equation. Say for example, when it have like point toward the NO2, you point this towards to NO2. But this time, okay, we are not running the whole equation once. We just have the whole equation divided by 2. If you remember, if I divided this one by 2, or you multiply this one by 2, the enthalpy change will also change accordingly. So in this case, if I divide this one by 2, I write it out. Say for example, I divide the whole equation by 2. Whole the equation by 2, then you have like NO plus half O2 becomes NO2. So this one, the delta H will then become negative 112 divided by 2. So I use this equation here, NO, half O2 to give 1 NO2. So this one, okay, it will be negative 112 divided by 2. So this one, I will write negative 112 divided by 2. Okay, so this one is a kilojoule per mole, okay. So the clockwise one, okay, the clockwise equation will be here. Starting point is here because every equation coming out. So starting point, end point here. So this direction add up together will equals to positive 34. Okay. So basically, So basically, you have like delta HF plus minus 112 divided by half equals to plus 34. So by rearrange them, okay, then you can calculate the formation one. Okay. So the answers will be here. Okay, you will see that, okay, it is positive. So therefore, at the end, you also have to give positive 90 kilojoule per mole. Okay. Next, okay, self-test. The questions, okay, we are having is this one. Okay, I will like put this one at the top, like a banner here. So that one will be a question mark. I don't know. I try to random use one equation. Oh, I forgot to put. Oh, you can see that. Okay, I forgot to put state symbol. That is wrong because state symbol is very important. Maybe in the process, okay, you are just converting state symbol. So this one is liquid to gas. So it's pointing towards the gas. Pointing towards the gas. So this one, okay, I will point towards a gas, and then this process will be positive 44. Okay, and then the other one is 2H2 plus O2 become 2H2O. But I just have one H2O here. Maybe I just have this one reduced by half. So you have like H2 plus half O2 and then become H2O gas. Okay, so this one you have to reduce by half as well. So we have gas already. Okay, and then we have one H2 and we have half O2. So you find that the whole things will be completed. But remember, this time I just have carry out the whole equation by half only. Okay, so we just have half of it. So basically, okay, the equation that you're going to do will be delta H F plus 44 equals to negative 483 times 1 over 2. Because the equation, this will be the clockwise, that will be the anti-clockwise. So I'll add these things together. So just take a short break here, okay? So the first few questions I just demonstrate, okay, just illustrate some basic techniques in doing the enthalpy change cycle. So next video it will be extension, and we'll just take a look of some advanced level in doing enthalpy change cycle. So this one is the summary, okay, the tips, okay, for constructing an enthalpy change cycle. So that's all for this video. Bye bye.